All right, boat A moves according to this vector equation, where t is greater than or equal to 0 seconds. That makes sense, we're not going back in time. And boat B has a different vector equation. However, their time parameter is not necessarily the same. So we're going to change them, because right now they look like they have the same t. We're going to change them to be t sub 1 and t sub 2, just to differentiate that they're actually different variables. That's t sub 1, and that's going to be t sub 2. And I get that I wrote that really small, so can you just try to remember what I said? Make that one t sub 1, make that one t sub 2. And now that we have different variables, now we can set these equations, the x part's equal and the y part's equal. So we want to know when the paths of the boat intersect. Okay, so you have two different paths of the boat. You want to know when they intersect. So we're going to set the x coordinates equal. So negative 1 plus 2 times t sub 1 equals 15 plus or minus. So I'm going to put plus negative 1 or plus negative t sub 2. You could put minus t sub 2. That would be a little bit more clear. And then for the y coordinates, we're going to do the same thing. I'm going to do it over here because I might want to simplify this a little bit. So for the y coordinates, I have negative 5 plus 3 t sub 1 equals negative 16 plus 2c, negative 16 plus 2t sub 2. All right, so just take a moment, make sure you know where those two equations came from. So what I'm going to do is I'm going to isolate my t sub 2 because it looks like the easiest to isolate. It only has a negative in front of it and doesn't have a coefficient, but it doesn't matter what you're going to isolate. You're going to isolate one of these, and then it'll be in terms of the other. So what I'll do is I will move my t sub 2 to this side, and I'll move these two over here. So I'll add my t sub 2 to make it go to the left, and then I'll add my 1 to move it to the right, and subtract my 2t sub 1 to move it to the right, and I still have 15 on the right. Okay, just a little bit of algebra 1 manipulation. I just didn't write down my steps, but I added t sub 2 to move it to the left. I added 1 to move it to the right, and subtracted t sub 1, 2t sub 1. All right, and then combining like terms, I have t sub 2 is equal to negative 2 t sub 1 plus 16. And since I isolated t sub 2 here, I'm going to do the same thing here. I have to isolate the t sub 2. So I'll add the 16 to move it over here. And then I'll divide by 2. Well, I'll combine like terms and then I'll divide by 2. So I have 3 t sub 1 plus 11 equals 2t sub 2. And then divide by 2. I'm just solving a system. You can solve systems in many different ways. You can solve systems by hand. You don't even need to use a calculator. So t sub 2, I'm going to use parentheses because that's what I'm going to do in the calculator. 3 t sub 1 plus 11 divided by 2. All right, so I'm going to graph those two and see where they intersect. And remember, all we're finding right now are the times, okay? So I'm going to graph these two. I'm going to use y and x instead of t sub 2 and t sub 1. Again, because I didn't record it. All right, so once you have it graphed in your calculator, put it in your y equals, and then we're going to do second, calculate, intersect, and enter, 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 and you're going to get 310. Now those are not the solutions for the intersection point, though. That's the times. So what we get is 310. And remember, since I solved for t2, that's my y. So this is my t2. And then t1 is 3. And then we substitute that back in to find the point where their paths cross. So you should get the same thing whether you substitute 3 into the first equation or 10 into the second equation. If you do both, though, it's like a check to make sure you got it right. So I'm still working on part A here, so I just made myself some more space over here. I have x, y equals -1, -5 plus time 1, so that's 3 times 2, 3. All right, so then 3 times 2 is 6 plus -1 is 5. And then 3 times 3 is 9 plus -5 is 4. And then, of course, since we're writing a coordinate, we're going to say their pass cross at, and then you're going to change it sideways because that's a coordinate, 5, 4. So, no. Boat A reaches 5, 4 at 3 seconds. And boat B gets there at 10 seconds. So we're all good. Okay, are there any questions on 8 before we do 9? So 9 is one more question about lines crossing. These lines are in 3D space. And so let's see how this one works. So we have an equation for line 1, and we have an equation for line 2. And we have an equation for line 3, they just wrote them differently. So these are written like as vector equations and these as parametric equations, but they really are the same exact thing. So it says, find if possible the intersection point of line 1 and 2. So what we're going to do is we're going to set the x's, the y's, and the z's equal and see whether they have a common solution, okay? For the x's, I have 1 minus s. Remember, we're just doing lines 1 and 2. So 1 minus s is 1 plus 2t. And then for y, it would be 0 plus s, so just s equals -1 minus t. And then for z, 3 minus 2s equals 4 plus 3t. All right, and I think I'm going to solve these for s, because I already have this s by itself. So for this one, I'll start by subtracting the 1. So negative s equals 2t, and then positive s equals negative 2t. And then this one here, negative 2s is going to be, I'm going to subtract the 3, so I get 1 plus 3t, and then divide by negative 2. And s is equal to 1 plus 3t divided by negative 2. All right, so we're going to graph these 3, and we have 3 lines, and 3 lines don't necessarily meet in one point. But if they do meet in one point, then that would mean that there would be a place where these lines cross. Okay, so go ahead and graph those, or remember, if you're going to use your simultaneous solver in your calculator, you would set them up differently. You would set them up with your s and t on the same side. Did anybody graph these yet?
I just did.
Do they cross at the same point?
I don't know how to see that.
Well, I'm going to hit graph. Oh, it does look like they do, right? We could zoom in a little bit if you wanted to. I'm just going to like zoom in by changing these to be -5s instead of, so -5 to 5 and -5 to 5. Oh, I definitely did that wrong. Definitely did that wrong. 1, -5, and 5. Yeah. So it looks like they're all going to meet at the same point. So I'm going to still do second, trace, intersect. 3 enters, and I get 1, -2, which remember is not the place where they intersect. So let's go back. 1, -2. 1, -2 is going to be, let's see, S is going to be my Y, so this is my S, and then T is my X, so this is my T. So to find the point where they intersect, you need to substitute, yeah, I'm going to do the 1 for the T, because that looks easier to me. So I have X, Y, Z equals this one. You could have put the other one in for S, that would have worked too. 1, -1, 4, plus 1 times 2, -2, oh, -1, my bad. Why am I even changing that? 3, 2, -1, 3, yeah, okay. All right, and so then if I add those up, I'm going to get the point 3, -2, 7, and that's where they intersect. All right, so if you're curious about lines 2 and 3, you can go ahead and try those. I'm just going to show you the equations because we're running a little bit short on time. We got a lot to do still. But I'll take questions on this first part. Any questions on the first part? All right, so remember that line 3 is written parametrically, but really it's the same idea as all the other lines. So when we're doing line 2 and line 3, we still set them up with X, Y, and Z. And you're still going to set the line 1x equal to the line 2x, the line 1y equal to the line 2y. Sorry, other way around, 2 and 3. So line 2, line 3, line 2, line 3, line 2, line 3. If you were going to use your simultaneous solver, then you would set them up with your x and your y on the same side. If you're going to graph them, you isolate one of the variables. But what happens this time is that they don't cross at the same point. Like all 3 of those lines are going to cross at different points, and so there's no solution to this one. Okay, so I'll leave that up if it's important to you to have it in your notes, but it's really the same idea. It's just that when you do lines 2 and 3, they don't cross at the same point, so there is no solution.